In this class, now I am going to explain you properties of chord of a parabola y square is equal to 4ax. See, this is known as a standard form of a parabola. So if we draw the graph of this parabola, we get like this. Y square equal to 4ax. So consider any 2 points on this y square equal to 4ax. So I am considering any 2 points on this curve, and let us say whose coordinates as x1 comma y1 and b coordinates x2 comma y2. Now my first point is find the equation of this line segment AB. Okay, so here name of the parabola is y square equal to 4ax. So on the parabola there are infinitely many points. I have given 2 points to you. I am asking you to find equation of this AB. So you learnt when we were learning the circles chapter, if any 2 points on the circle are given, how did we calculate equation of a line? By applying this rule S1 plus S2, which is equal to S12. Okay, you know the notation of S1, S2, S12 for this parabola. What is S1? So first this 4ax you have to send it to the left side, so that this must be represented by y square is equal to 4ax. Next S1 y1 minus of 2a of x plus x1. What is S2? y2 minus 2a of x plus x2. Similarly, what is S3? Sorry, S12. So y1, y2 of 2a of x plus x1 plus x2. Okay, prepare this S1, S2, S12 with respect to this point A and B, so that you will get equation of that chord AB. Okay, right. Next, see, but here in the previous one I gave you A and B in Cartesian form. If I give you these points in parametric form, see, both points I am giving you in terms of parametric. So AT1 square comma 2AT1 and B coordinates AT2 square comma 2AT2. What is the name of the parabola? Y square equal to 4ax. Now find the equation of this chord AB. So how did you find? So same, apply that previous rule S1 plus S2, which is equal to S12 with respect to this parabola. Okay, so that you will get equation of this chord AB. Otherwise, so here actually AB is a chord now, which is nothing but a line segment. When the 2 points on the line are given, how to determine the equation of a line, so you learnt, okay, in the straight lines chapter, when the 2 points on the line are given, how to determine the equation of the line. So apply the 2 points form of a line equation, so that you can able to find equation of this chord. So instead of applying this rule S1 plus S2, which is equal to S12, so to find the equation of this chord, here I am using the 2 points form of a line equation. Okay, you know that. So y minus y1, which is equal to y2 minus y1 by x2 minus x1 of x minus x1. Now here consider this one as x1 y1 x2 y2. Okay, so substitute here. What is y1 here? 2a t1. So which is equal to y2 here 2a t2 minus y1 2a t1 whole by x2. Here this is x2, this is x1. A t2 square minus a t1 square of x minus x1. So a t1 square. Now simplify this. On simplifying, so here we get y minus 2a t1. From the numerator you can take 2a outside, t2 minus t1 whole by take a common, and here what is left? T2 square minus t1 square. That can be written as t2 plus t1 into t2 minus t1 half x minus a t1 square. So these two can be cancelled. Okay, so hereafter okay, here these two are cancelled, and a also you can cancel. So in the next step, so multiply this left side one with this t2 plus t1. Y minus 2a t1 into t2 plus t1, which is equal to 2 of x minus a t1 square. So now write multiply. So y1 I am multiplying with these two. Y of t2 plus t1. So here minus 2a t1 into t2 plus t1. So which is equal to 2x minus 2a t1 square. Y of t2 plus t1. Multiply these two terms with this 2a t1 t2 minus into plus minus 2a t1 square. So which is equal to 2x minus 2a t1 square. Now both terms are like terms lying either side of the equal. Hence you can cancel these two. So in the next step, transfer this one to the right side. Y of t2 plus t1, so which is equal to 2x plus 2a t1 t2 is the required equation of that chord AB. Okay, right. So suppose if this chord is a focal chord, what is the condition? So here this is y square equal to 4ax curve. So we have taken a and b over here. Suppose if it is focal chord. Focal chord means what? It must passes through focus of this parabola. So here somewhere over here you will get the focus whose coordinates a comma 0. Okay. So suppose if it is passes through this focus, then this point is lying on this AB chord equation, no? So that I am replacing this y and x by these 0 and a. Now put y equal to 0. 0 of t2 plus t1, which is equal to 2 of a plus 2a t1 t2. 0 into something 0 here, what is left? Okay, take 2a common from these two terms. 0 is equal to 2a of 1 plus t1 t2. When you bring this one to the left side, 0 is equal to 1 plus t1 t2. Now t1 t2 is equal to minus 1. Okay. So this is the required condition to become this chord as a focal chord. Right. Suppose if it is a focal chord, so one of the extreme we have taken as a t1 square comma 2a t1, and other one we have taken as a t2 square comma 2a t2. So for this focal chord, Okay, we got this condition T1 into T2 is equal to minus 1. Now from this T2 is equal to minus T1 we get. Now in the other end, this is one end of the chord and this is other end. In the other end, okay, replace in the place of T2 by minus 1 by T2. If you replace this T2 by this, then this B coordinates will become A by, so minus 1 by T1 whole square becomes A by T1 square. So here it is minus 2A by T1. Okay. So for the focal chord, so one end if you take as A T1 square comma 2A T1, then other end what do we get? A by T1 square comma minus 2A T1. So if you take this end, A coordinates as AT square comma 2AT, and other end we get A by T square comma minus 2A by T. Okay, right. Hereafter, now I am going to find the length of this focal chord. Okay, right, measure this length of this focal chord AB. Right, so you know, to measure this distance from A to B, we have distance between 2-point formula. Apply that. So if you apply that, what do we get? See, consider this one as x1. See, x1, y1, x2, y2. Right, square root of difference of x coordinates. So what do we get here? A by T square minus AT square plus difference of y coordinates. So minus 2A by T minus 2AT. Okay, right. Now simplify this. On simplifying this, what do we get? So here A you can take common A square, and here also minus 2A you can take whole square, but while it is coming out it will take whose exponent? Square is there. So finally what do you get on simplifying this? A will come out. Okay, so here if you would like to write the mod symbol you can, because it should be positive. Alright, here what do we get? 1 by T square minus T square full square, and here minus 2A whole square went outside, here 4 will come. So 1 by T plus T whole square will come. So in the next step A, so you observe carefully, inside of this bracket here A square minus B square is there. So now that I want to write, so 1 by T plus T whole square and 1 by T minus T whole square plus 4 of 1 by T plus T whole square. Now in the next step, here this one and this one I am going to take outside, so that here we will get A of 1 by T plus T. So inside what is left? 1 by T minus T whole square plus 4. Okay, here observe carefully. So this one, so here wantedly I want to write 1 by T here and T in the numerator. Can we write? So in the next step what I am going to do? Can you guess? See here, it is looking like A minus B whole square plus 4AB. So hence that can be written as A plus B whole square here, A minus B whole square plus 4AB. You know that identity, apply that, so that here we will get A plus B whole square, A minus B whole square plus 4AB equal to A plus B whole square. A means here 1 by T, B means T whole square, square root cancel. Now A 1 by T plus T and 1 by T plus T. So then whose product will become A of 1 by T plus T whole square units. This is the length of focal chord AB, because that chord is passing through the focus. Hence, this is the length of the focal chord. Actually, if it is not a focal chord, okay, if it is normal chord, then how do you find? See, for the normal chord, so we have taken the ends of the chord AT1 square comma 2AT1 and B AT2 square comma 2AT2. So just apply distance between the 2 points. So what do we get? AT2 square minus AT1 square plus here 2AT2 minus 2AT1 whole square. Okay, now again here A square will come out, here 4A square will come out. So A of square root of T2 minus T1 whole square plus, so here 4 of T2 minus T1 whole square. So here inside square. Yeah, in the next step, this inside one I am going to write as A plus B into A minus B whole square is there. So that here you will get T2 plus T1 whole square and T2 minus T1 whole square plus 4 of T2 minus T1 whole square. So in the next step here, these two are like terms now. Take outside, which will come as A of T2 minus T1 square root of, inside what is left? T2 plus T1 whole square. Okay students, T2 plus T1 whole square plus 4 units. So here itself you have to leave. So this is our required length of the chord AB. This is not a focal chord. For the focal chord, so we have got A of 1 by T plus T whole square. Okay. Now, see students, for the focal chord here, what is the name of this parabola? Y square equal to 4ax only. We are okay, discussing all these properties for this y square equal to 4ax parabola only. So suppose here AB is a focal chord, you know, which passes through focus A comma 0. So consider the extreme coordinates as AT square comma 2AT. Then other end will be how much? A by T square comma minus 2A by T. Okay, right. Now here these two are the extremes of this focal chord in the parametric form. In the Cartesian form, how do we take? X1 comma Y1, X2 comma Y2. Now my question is, take the product of abscissas. Take the product of abscissa of A and B. You know the meaning of abscissa. X coordinate of other name is known as abscissa. What is ordinate? Y coordinate of a point is known as ordinate. Okay, what they are asking us here? Product of abscissas. Now get it. So x1 is AT square into x2 A by T square. T square cancel. A into A square is the product of abscissas. Similarly, can you find product of ordinates y1 into y2? So here, there 2AT into here minus 2A by T. TT cancel. So minus 4A square is the product of ordinates. Next, Okay, in the beginning of this parabola, we learned the meaning of a focal distance. What is the meaning of focal distance? So on the parabola, there are infinitely many points are there. If we measure the distance from focus to any one point on the parabola, then that is known as focal distance. Okay, right. You know the standard form of the parabola. See here, y square equal to 4ax. Here, take focus as a comma 0. Now take a point P over here, whose coordinates x1 comma y1 in Cartesian form. If you measure the distance from S to P, you will get mod of x1 plus a. Am I right? This is called focal distance from S to P. Just apply the distance between 2 points. In that simplification, in the place of y1 square, you have to write 4ax1 and simplify. You will get mod of x1 plus a as focal distance. Okay? I think you have understood the meaning of focal distance. The distance measured from focus to any one point on this parabola is known as focal distance. Okay? So suppose if you take this point coordinates in parametric form like 80 square comma 280. Here what is x1? 80 square right here. So 80 square plus a. Okay, as length of this focal distance, which is measured from S to P in parametric form. So here infinitely many points are there on the parabola. Among all that, so this vertex is the nearest from focus. Okay, which focal chord length is minimum? If you measure the focal distance from vertex to the S, that length of the focal distance is small than other points. So that you can say as vertex is the very nearest point from the focus. Right. Next, okay, how many focal chords can you able to draw? Okay, you can draw many more focal chords. Okay, the chords which passes through focus. This is S, a comma 0 for y square equal to 4ax. So infinitely many focal chords you can draw. Among all that, this latus rectum is minimum length. What is the minimum length of the focal chord? Latus rectum only, whose length is known to us 4a. The length of minimum focal chord is 4a. That is length of the latus rectum. Latus rectum is also one of the focal chord because it passes through the focus, no? So whose length is very small than length of other chords. Observe that point. Next, see students, x dash, y dash. Now y square equal to 4ax. So this is focus, whose coordinates are a comma 0. Right students, see here. What is this? Focal chord. So AB is focal chord. It is making an angle theta with axis of the parabola, that is x-axis. Then find the length of AB. Okay students, what you would have to calculate here? So length of the focal chord, which is making an angle theta with axis of the parabola. Now find whose length AB. Okay, how do we find it is a focal chord? No. So whose length, how much have we got? AB as A of 1 by t plus t whole square we got. But we people want this length in terms of this theta. How much is this? Tell me. So for this here, observe me what I am going to do. So let us consider A coordinates as at square comma 2at, and B coordinates a by t square comma minus 2a by t. Okay, so students, drop a perpendicular from A to this axis of the parabola. What I have done, I have dropped a perpendicular distance from A to this axis of the parabola. How much is that? 280. The distance from here to here. Let us take this point coordinates as P. Now measure this S to A. Distance from S to A. How much do you get S to A? Square root of. So students, here measure from here to there. A minus at square whole square and 4 a square t square. Now simplify that, S to A. So here a square again take common, which will come as A. So here 1 minus t square whole square plus 4t square. Now A of square root of, what do you write this? A minus b whole square plus 4ab. So it can be written as 1 plus t square whole square. Square root cancel. A of 1 plus t square you will get. So from S to A, distance is how much? A of 1 plus t square. A of 1 plus t square. Right, in the next step, see, so here SPA is a right angle triangle, no? So define sine ratio with respect to this theta, so that what do you get? Sine theta is equal to, so opposite is 280 by hypotenuse A of 1 plus t square. Now this A cancel. So now sine theta is equal to, what we got? 2t by 1 plus t square. But from the denominator, now I would like to take t common. When you take t common from these two, here you will get t plus 1 by t. Am I right? So if you want, again send t inside, t into t square, and t into this, t cancel, 1 will come. So here t cancel. What is left? Sin theta, which is equal to 2 by t plus 1 by t. Now take reciprocal on both sides. 1 by sin t, which is equal to, okay, here what do you get, amma? T plus 1 by t by 2. Now bring 2 to the left side. So that what do you get? T plus 1 by t, which is equal to, so here 1 by sin theta is nothing but cosec theta. Now when you take 2 left side, 2 cosec theta you will get. Okay na? So t plus 1 by t is how much? 2 cosec theta. Right. Next to. Actually what we are doing here, we are finding the length of AB, no? Already. So we know the length of AB is equal to A of t plus 1 by t whole square. Okay? Right. Now A. So t plus 1 by t is 2 cosec theta, no? Here whole square is there. So if you write 2 cosec theta over here, then you will get AB length is 4a square cosec square theta units. So this is our required length of this chord, focal chord, in terms of theta. Okay, right. Next, see x dash, y dash. Students, see here, this is standard form of the parabola. Y square equal to 4ax. This is vertex whose coordinates 0, 0. Now, this is one chord. Am I correct? So here, this origin is one of the point and this is one of the point. So connect these two so that we are forming a chord. This chord is making an angle theta with respect to this axis of the parabola, that is here x-axis. Now determine this OA length. Origin is taken as O. Find the length of a chord which passes through vertex of this parabola. Okay, that is OA. Now find OA length in terms of theta. I hope you have understood. What we are doing here, we are finding the length of a focal chord OA. Sorry, not focal chord here. It is normal chord only, not focal, because it is not passing through the focus now. Right. Determine this OA, which is making an angle theta with axis of this parabola. Same, how do you find this one? Same like previous one only. First, you have to consider this A coordinates in terms of parametric. 80 square comma 280. So in the next step, we want OA length, but here I am taking some construction. I am dropping a perpendicular from A to this axis. That is how much? 280. So you know the length from here to here. Consider this point as P. So O to P length is how much? 80 square. Okay. Now actually what we want? The distance from O to A. O to A is how much, Amma? So square root of A t power 4 plus 4 AT square. Now from both, what do you take common? So A square. Okay. So what can you take common from these two? Right. So here A square t power 4 and 4A square t square, right? So take A square common here. A square t square outside, AT will come out. When you take AT will come out, when you take AT as common from both terms, here what is left? AT square, and here 4 will come. AT, and so here only t square plus 2 will come. Okay, because here A square t square, here A square t square we have taken common, this is left. Okay, keep it aside and come here and define sin theta or cos theta. So what I want to define here? So define sin theta. Sorry, tan theta. You better to define tan theta. Tan theta is how much? Opposite by here adjacent 2AT by AT square. Now AA cancel. So 1T cancel. 2 by T. 2 by T value tan theta. Okay. Then T is equal to how much? Tan theta is equal to 2 by T. Then theta will be 2 cot theta. So T is equal to how much? 2 cot theta. Am I right? See here, T, make T as subject so that you will get 2 cot theta and substitute here. So A of A into 2 cot theta. So square root of T square 4 cot square theta plus 4. Now take 4 common. When it is coming out, okay, it will get 2. 2 2 is a 4. 4A cot theta, inside cot square theta plus 1, that is nothing but cosec square theta. So square root to cancel, cosec theta, 4a cot theta into cosec theta is the length of that OA. Still, if you want to simplify, you can. So, okay, in some textbooks they write this cot theta as cos theta by sin theta into cosec theta. So, again, this 1 by sin theta can be written as cosec theta. Cosec theta into cosec theta, cosec square theta. So that you will get 4a cos theta into cosec square theta is our required length of this chord OA in terms of this theta. Theta is the angle between this chord and axis of the parabola. Right? See the next point. So remember, like a standard result, x dash, y dash. So take the standard form of the parabola y square equal to 4ax, and whose directrix we get here. This is a equation of directrix of that parabola, that is x plus a equal to 0. We know this. So here it is one focal chord. Okay. What is AB? Focal chord. Now take AB as diameter and draw one circle, compulsory, which touches this directrix. Okay. If you draw the circle by taking AB as diameter, then that circle touches directrix at one point. Suppose if you draw the circle by taking, see this is parabola. Okay, yes, here you can take one point A. So draw a circle by taking this focal distance as diameter, then you will get a circle like this. Okay, so now this circle is touching the tangent which is drawn at the vertex. Okay, this is a parabola and a focus. So here what is this? What is this? SA is a focal distance. I am taking this SA as a diameter. Like this you will get. Okay. Take SA as diameter and draw one circle. So which touches this tangent which is drawn at vertex of this parabola. Take focal distance as diameter and draw one circle which touches the tangent of this parabola drawn at the vertex. Remember this point. Next. Okay. See here. Y dash, x dash. This is origin. Now what is this standard form of the parabola? Y square equal to 4ax, and you know this is focus. Take whose coordinates as a comma 0, and let us take this SP focal distance, and this is SQ also focal distance. So this SP is one line segment, and this is one more segment which are nothing but focal distances. So then find 1 by SP plus 1 by SQ is equal to how much? Okay, this PQ is a focal chord. So SP is one of the segment made by that chord, and SQ is one more segment on this PQ. This S is dividing PQ into two segments. So SP is one segment, SQ is one segment. So then measure 1 by SP plus 1 by SQ is equal to how much? So for this what I want to do, I would like to consider P and Q coordinates in the parametric form. So A coordinates, shall I take A T square comma 2AT, and Q coordinates will be, right, tell me students, how do I take? Okay, your wish. Here if you want to take, this is AT1 square 2AT1, and this is this will be A22 square comma 2AT2. Otherwise other end can be taken as A by T square comma minus 2A by T1, your wish. Okay, so but I want to take whose extremes like this only, and hereafter I would like to find SP length, the distance from S to P. How much do we get? Right, A minus difference of x coordinates, AT1, A minus AT1 square whole square plus 4A square T1 square. Now take A square outside, so inside here 1 minus T1 square whole square plus 4T1 square. So this can be written as A of 1 plus A minus B whole square plus 4AB, which is equal to A plus B whole square. Square root to cancel, this much will be left. Okay, for SP. SP length is how much? A of 1 plus T1 square. Similarly, this SQ, other end I would like to take as A by T square comma minus 2A T1 square only. One end I have taken as AT1 square comma 2AT1 now. For the other end of the focal chord, you can take A by T1 square comma minus 2A T1, you know that. So, okay, SP this much you got, but here 1 by SP is there. 1 by SP means this has to be reciprocal. So 1 by A of 1 plus T1 square you will get. 1 by A of 1 plus T1 square. Keep it aside and measure SQ length. SQ, how much do you get? SQ square root of, take the difference of this A minus A by T1 square whole square plus this is 4A square T1 square. Now take A square outside, square root of 1 minus 1 by T1 square whole square plus 4 by T1 square. So now A square square root of A minus B whole square plus 4AB again. So you can write 1 plus 1 by T1 square whole square, square root to cancel. So finally we will get, okay, reciprocal of SQ, reverse of this. So if you simplify this one, so here you will get, sorry, here when it is outside, which will come as A only, not A square. A of 1 plus 1 by T1 we will get. A of 1 plus, okay, T1 square. Now cross multiply. So if you simplify this, what do you get? A of T1 square plus 1 by T1 square. Okay. Then what do you get in the next step? Students, observe carefully. A of, when you take reciprocal, T1 square by A of 1 plus T1 square. Right. In the next step, from both denominator, what here? Denominator is same now. So in such case, you can add the numerator. A of 1 plus T1 square. In the numerator, 1 plus T1 square. Both are cancelled. So 1 by A. 1 by SP plus 1 by SQ is equal to how much? 1 by A. So in the next step, I am multiplying numerator and denominator with 2. 2 by 2A. Okay, 2 by 2A. Now 2 by 2a means what? Half of the length of latus rectum. What is the length of latus rectum for this y square equal 4ax? 4a. So here, this is length of the latus rectum, L dash. Whose L dash length is 4a, but here you got 2a, no? So you can say this 2a as length of semi-latus rectum. Length of semi-latus rectum. Length of semi-latus rectum. If you take this length of semi-latus rectum as L, then this is equivalent to 2 by L. Here what is L? Length of semi-latus rectum. Okay? Actually latus rectum length is 4a, no? Half. So that half length is 2a. So that one I am representing with here L. So what you got? 1 by SP, 1 by SQ, which is equal to 2 by L, means, okay, this SP, comma L, comma SQ will form a harmonic progression. SP means one of the focal distance, and L half of the length of latus rectum. SQ one more focal distance on this PQ chord only. So these three lengths are forming a harmonic progression. Okay, observe that. SP and L comma SQ are in harmonic progression. Right. Next here I am asking you one question. Please answer to it. X dash, y dash. See, y square equal to 4ax. Now my question is, see here, this is focal chord. Okay, let us consider ends of this focal chord as A and P. So this SA, SB are two segments formed on this focal chord by the focus. This focus is dividing AB focal chord into two segments. One is SA, one is SB. Let us consider this SA length be L1 and SB length be L2. Then, okay, find the length of the latus rectum of this parabola. What are given to you? Lengths of segments on focal chord as L1, L2. What are segment? Understood in this figure? It is a focal chord. This focus is dividing this focal chord into two segments. One is above, one is below. Above one I have taken L1, okay, this bottom one I have taken L2. Then find the length of the latus rectum of this parabola. How do you find? Just now I said to you, 1 by SP plus 1 by SQ, which is equal to 2 by 2A. Otherwise 1 by A. Okay, now use this relation. 1 by SP L1, 1 by SQ L2, which is equal to 1 by A. Now simplify, take cross multiplication so that you will get L1 plus L2 by L1 L2 is equal to 1 by A. Now reciprocal on both sides so that you will get A is equal to L1 L2 by L1 plus L2. But we want length of this latus rectum. L dash. You know L dash length. L dash is equal to 4A. But here A you got L1 L2 by L1 plus L2, no? Substitute here. 4L1 L2 by L1 plus L2. Okay. So this is our required length of the latus rectum in terms of L1 and L2. L1 and L2 are two segments formed on the AB focal chord. Okay. Right. Next. See students, next I am going to discuss one more Okay, small subtopic of this chapter, that is intersection of a line and a parabola. You know, okay students. So here this is one parabola and one line. If you would like to draw a line and the parabola on the plane, three ways you can draw. No relation is there between the parabola and the line. Here it is tangent. Here it is, okay, like you can say it as chord or secant. It is intersecting the curve at two distinct points. Okay, this many ways you can draw a line and the curve on the plane. Even same concept we have discussed in the circles chapter. Okay, so what you people have to do, because we don't know the exact diagram, so whether the given line is a tangent of the curve or a secant of the curve or no relation, how do you say? So I said to you, see here, they use it to give curve equation, they use it to give a line. Okay now, so in the curve equation, wherever y is there you have to write this mx plus c. Okay, and we frame a quadratic equation in terms of x by replacing y by this. One line and one curve will be given to you. From the line you have to make one variable as subject, either x or y. So here I made y. This y I am substituting here, so that you will get one quadratic equation in terms of x, and for that we need to find discriminant value. If it is okay positive, then that line will be called secant to that curve. If the discriminant becomes 0, then you can say that line as tangent. If the discriminant value is less than 0, means negative, then no relation is there between the line and the curve. The same concept must be applied to here. Okay, now what I am asking you, write the condition for this line y equal to mx plus c, okay, is a tangent and secant and no relation. So what is the standard form of the parabola? Y square equal to 4ax. Okay, one line equation is given, one parabola is given, whether it is a secant or tangent or no relation. Check. So what I have to do? So I have to replace this y by this mx plus c. So every time line equation may not be given to you like this. They may give ax plus by plus c equal to 0. But you make sure that you make y as subject. Okay, you got the y. Okay, now substitute over here. Mx plus c whole square, now which is equal to 4ax. Now simplify this. So simplify. What do you get, Amma? M square x square plus c square plus 2mcx, now which is equal to 4ax. Now here m square x square. So transfer this one to the left side so that you can take x common. So here 2mc minus 4ax plus c square, which is equal to 0. Now we got a quadratic equation in terms of x. Now for this apply the delta. Find the discriminant value, b square minus 4ac. b square means 2mc minus 4a whole square minus 4ac, 4m square c square. Okay, so right, in the next step, see here, simplify that. A minus b whole square. So a minus b whole square here, 4 m square c square plus 16a square minus 16 mca minus 4m square c square. Now these two are cancelled. From both, what do you take common? 16a you can take common. Here a minus mc you will get. This is the discriminant value of this quadratic equation. Okay, suppose if that line is a tangent, then what did I say? Delta equal to 0. Equate this one equal to 0, so that you will get a is equal to mc. This is the condition for that y equal to mx plus c is a tangent of y square equal to 4ax. Suppose if it is secant, means intersects at two distinct points. Delta is greater than 0 means here you will get A is more than MC. No relation. So delta less than 0, A less than MC you will get. Okay na? Right. Next. Here you would have to learn one more problem based on this. So measure the intercept made by the parabola y square equal to 4ax on y equal to mx plus c. Find the intercept made by y square equal to 4ax on y equal to mx plus c. How do you find? See, this is y square equal to 4ax. Now this is the line whose equation is mx plus c. Now here you would have to measure this length from A to B. Okay, how do you do? So consider this A coordinates x1 comma y1, B coordinates x2 comma y2. Okay, right. How do you do this? Tell me, students. So you know the distance from A to B, which is equal to x2 minus x1 whole square plus y2 minus y1 whole square. So here, if you write here, the next step what you have to do? x2 minus x1 whole square. Here what is y2? If you write here y2 value over here, then it will become 4a x1. So here 4a x2 minus y1 4a x1 whole square. So what do you write here in the next step? x2 minus x1 whole square plus 4a take outside, which will come as 16a square, and x2 minus x1 whole square. So both you can take outside. When you take outside x2 minus x1 mod, so inside, so 1 plus 16a square you will get. 1 plus 16a square. Am I right? Okay, right. So here we want x2 minus x1, difference of abscissors of this A and B. For that, observe me what I am going to do. So now replace y by mx plus c in that, so that you will get mx plus c whole square, so which is equal to 4ax. Now simplify same like a previous one. M square x square plus c square plus 2mcx, which is equal to, right side 4ax is there. Now bring it to the left side, so that you will get m square x square plus 2mc minus 4a x plus c square, which is equal to 0. Now it is a one quadratic equation in terms of x. On solving this quadratic equation, you will get two values for x. Let us take one point as x1 and other one as x2. Okay, right. Now x2 minus x1, if you want, what you have to do? You know, a minus b can be written as a plus b whole square. Sorry, a minus b is equal to a plus b whole square minus 4ab. 4x1 x2. So x1 x2 are the roots of this equation now. So here x2 plus x1 means we want the sum of the roots. Sum of the roots formula, you know, minus b by a minus b. B means this one, no, minus becomes positive because whole square is there. So here 2mc minus 4a by a. A means m square minus b by a whole square minus 4 into x1 x2. x1 x2 is how much? C by a. So here c value c square by a value m square. Now simplify this. So there we got AB length how much? So x2 minus x1 of root of 1 plus 16a square. Keep it aside, and we are finding the length of x2 minus x1. So what do you take common here? M square will be outside, 1 by m will come inside of the square root. Okay, students, simplify. Here you can take 2 outside, here 2 outside. So 4, 4. So 2 by m will come out. So here mc minus 2a whole square will be left. Here minus. So 4 c square. Now simplify that. 2 by m square root of m square c square plus 4a square minus 4mca minus 4c square. On simplifying this, what do you get? So from these two you can take c square common. So from these two you can take 4a common. So c square of m square minus 4, and from these two you can take 4a common. If you take 4a common, so here 4a common, a minus, students, 4a went outside, mc will come. Okay students, still any simplification is possible? Once check it students, I think okay, so this is our required x2 minus x1, and substitute this x2 minus x1 over here. Okay, so this will be our length of AB, so which is formed by a line y equal to mx plus c on y square equal to 4ax. Thank you.